Let's take a look at 2/3 times 1/2. So if we start at 2/3 and we're here on the number line and we multiply by 1/2, all we're doing is cutting this 2/3 in half. So halfway from 2/3 to 0 would be 1/3. Now it makes sense because the 2/3, here's the 2 that we originally have, 2 out of 3/3, but we're essentially reversing that and cutting it back in half and going 1 back. So in essence, what's happened is we've taken the two 2's and canceled them out and left with what we started. Well, we're left with the numerator over here, the 1, and the 3 over here in the denominator. So the 2's went away and we're left with 1/3. Let's take a look at another example. 3/4 times 4/1. So 3/4 times 4/1. Okay, 3/4 is right here on the number line, and if I multiply that by 4, I have 1, 2, 3, 4. I end up with 3. Now the best way to think about this one after I got looking at it was, what is 3/4? Well, actually it's just taking 3 and dividing it by 4. 1, 2, 3, 4, right? And so this would be a fourth of 3/4. A fourth of 3. Now, if I multiply that by 4, I'm basically just undoing what I did. So 3 divided by 4, I'm dividing it into fourths, and here's my fourth of 3. If I multiply that by 4, I go back to where I started. And again, we see kind of the same thing, except this time, these two number cancel. Let's use a different color here. These two numbers canceled, and we were left with the numerator on the top left and the denominator on the bottom right. 3 divided by 1 gives you 3. So again, we see that the 4 cancels because we divided by 4 and then we multiplied by 4. Whereas in this example, we multiplied the third times 2, I guess you could say, and then divided by 2 to go back to a third. So more or less, we're seeing that the division and the multiplication cancel each other. And we're going to reach a general conclusion here in a second. If we have negative 3/4 times 4/3, it's kind of a double whammy, because we have 4 here, and a 3 here, and a 3 there. So what happens here is, first of all, we have negative 3/4. Now, if we divide, let's go ahead and divide by the 3 first. So if we divide by 3, we actually end up at negative 1/4, right? Because here's 1, 2, 3. So here would be a third of that, negative 1/4. But if we take that and multiply that by 4, we'd have 1, 2, 3, 4, and we end up with negative 1. Therefore, in this particular example, both the 3's canceled, and let's use another number, color, and the 4's canceled, and therefore we were left with only the negative sign, and of course 4 divided by 4 is 1, so anytime you cancel both, you actually end up with a 1, not a 0. And the way to look at this one, I actually drew the hops out. So here's the 3/4, right? Now, again, if we divide that into thirds, here would be a third, but if we multiply that back by 4, we get the purple, and we end up back at negative 1. So in that case, we see that basically everything cancels except for the negative. We end up with a 1 on top, and the answer is negative 1. So negative 3/4 times 4/3 is negative 1. Here's kind of a formal proof of why these I'll go ahead and tell you, this is called cross-canceling in math. And I will explain in a second the dangers you can run into when doing this, but it saves a lot of time. It's just more or less a shortcut. So if we have a over b times c over a, we already talked about how to multiply fractions together. So we'd have a times c on top, and we have b times a on the bottom. We already talked about the fact that the order in which you multiply two numbers doesn't matter, so the c can come before the a. So now we have c times a on top, and we still have b times a on the bottom. Now what we're going to do is re-break them apart into two different fractions, because if you can go this way, then you can certainly go this way. So if you can multiply two fractions together to get one fraction, you can break the numerators back apart and the denominators to form two fractions. So anyway, now you have c over b times a over a. We know that a over a is equal to 1, and anything times 1 is itself. Therefore, we're left with c over b. So what happened was we started with a over b times c over a, and we ended up with c over b. In other words, the a's went away. So cross cancel the a's, a over b times c over a, just cancel the a's out, and you end up with c over b because of this proof we just looked at. And if you want to look at it a little bit slower, you can slow the video down and take a look at each individual component. It works the same way as if we do c over a times a over b, because those are the same thing. All we're doing is just reversing the order of them. So again, it's the same thing, but the order switched. The a's will still cancel, and you'll still be left with c over b, or whatever those numbers are. Remember, those are variables that could represent any number. 4/5 times 5 over 7, or whatever, you'd end up with 4/7. Okay. Now, how does it work when you have both the same? Well, if you have a over b times b over a, I shouldn't say both the same. How does it work when you have two cancelizations? So a over b times b over a is going to become ab on top and ba on the bottom. And then we can switch the top or the bottom, doesn't matter. We'll switch the bottom. So the bottom ba will become ab. Now we have ab over ab, and anything divided by itself is 1, so you could stop there, or you could break it apart into two fractions again. So this is a over a times b over b. A over a is 1, b over b is 1, 1 times 1 is 1. So therefore, a over b times b over a is 1. Another way of looking at it is just everything basically cancels out, and you're left with 1. Now, again, I gotta say that when everything cancels in something, you're left with 1, not 0. Just remember that, because anything divided by itself is 1. So as I said before, this is called cross-canceling fractions. This is just a general slide illustrating one of the ways they cancel. Again, the a's can be, as long as one a is on the numerator and one is on the denominator, or x or y or whatever, they can cancel. Now the thing you want to stay away from, I've seen students cross-cancel when you have an equation. Like if you have an a in the numerator of one equation and an a in the denominator of another, it doesn't work that way. Okay, it only works for expressions. Basically, when you're multiplying 2 or 3 or 4 fractions together, you can do this. Now, again, if you have an equation or an inequality, that changes things. If the variable's on two different sides of the equation, you cannot cross-cancel, so do not fall into that trap. Okay, let's go ahead and look at the first official example, 10 over 7 times 2 over 10. There's really not a whole lot going on, but again, I want to show you just a few simple steps in case you kind of forget how to do these. Go ahead and cross cancel, and when I say cross cancel, I mean the numbers that are similar on the top and bottom. Okay, you can't cross if there was a 10 but you know, the top, a 10 on the left and a 10 on the right, both numerators, you can't do that, right? You're canceling a numerator with a denominator. So in this particular example, we're canceling the 10 on the numerator there with a 10 denominator over there. And it's called cross-canceling because one's in one fraction, one's in the other. But it's simple, right? It saves the time from having to switch the numbers and everything. So once you cross-cancel, then you can simplify, and in this case, you're left with a 2 in the numerator and a 7 in the denominator over there. But again, it won't matter. You'll just end up with one fraction, 2 on the top and 7 in the bottom. So therefore, our final answer for this one is 2 over 7. And just in case you're wondering that, well, in this, why can you just write 2/7? Because 10 over 10 is 1, right? And 1 times 2 over 7 just gives you 2 over 7. And therefore, you don't have to write 1 times 2 over 7 every time. You can just write 2/7 when that cancels. So 10 over 10 is 1. 1 times 2 over 7 is 2 over 7. Okay. Y over x times x over a. And again, we do these examples not so much to focus on the constant numbers, but to focus on the variable numbers as well, because variable numbers change, and we want to get used to doing algebra. A lot of algebra involves numbers that change. We don't want to just see them as letters, we want to see them as numbers that change. So there's an x here in the denominator, and then on the other fraction, there's an x in the numerator. That tells us there's going to be some cross cancellation. So we're going to cancel the x's. Again, one has to be in the numerator and one has to be in the denominator. So now that we've done that, we're left with a y in the numerator here and an a in the denominator there, and we can form that as one fraction. Because again, x times x over x, when the cross cancel gives you 1, y times 1 is y, and then you have an a on the bottom. So, final answer is y divided by a. It's very, very simple. But it's important you understand why this works. Okay, so now let's look at this one together. We have b over c times c over b. Now notice that we have a c in the denominator and numerator, and we also have a b. We have b's in the numerator and denominator. So that means we're going to have a double cancellation. And again, when everything cancels out, basically you have a 1 on top and a 1 on the bottom, and that just becomes 1. So final answer for this one is 1. Let's get a little bit more advanced, even though we don't want to focus on anything too complicated right now. xy over 3 times negative a over xy. Now what you should notice is we have an xy up here and an xy down here. Even though it's a little bit more advanced expression, it's still going to cancel. Okay, even if it was like square root of 3 plus x squared on top and square root of 3 plus x squared on bottom, they're the same thing. They're ultimately going to be the same number because that x has to represent the same thing. So they're going to cancel no matter what. So we're going to go ahead and cancel the xy's, and we're left with negative a on top and 3 on bottom. And one more step, I've told you guys, if you have a negative in the numerator and denominator, go ahead and move it out in front of the fraction. We've already talked about why that is. So the final answer is negative a divided by 3. Okay, 6 over the square root of 7 times the square root of 7 over 10. So what do we have the same on the top and bottom? Well, if you're looking, there's a square root of 7 in the bottom of this fraction. Try this again. And the square root of 7 on the top of this fraction. So that's going to mean cross cancellation. Now for this particular example, we're left with 6 and a 10. And we need to go ahead and simplify that. They both have a 2 in common. So we're going to divide both the top and bottom by 2. And we end up with 3/5. Therefore, the final answer for this one is 3/5. Okay. How about this one? Negative 2/5 divided by 4 times pi over 2/5. I realize that negative 2/5 and I'm sorry, I read that wrong. Negative 2.5 divided by 4 times pi over 2.5. Okay, I realize that negative 2.5 and 2.5 are not the same, but 2.5 is the same as 2.5, so you can cancel them in the sense that, yes, you cancel them, the negative remains, okay? And so that's another thing that occurs when you cross cancel. You can cross the numbers themselves out, and the negative will stay there. So just remember that. And that's because the negative 2.5 divided by 2.5 is just negative 1, right? So negative 1 times whatever this is just going to give you the negative of that number. In this case, it's negative pi. And that's why that works that way. And we've already talked about negative 1 times anything is just the negative of that thing. So final answer for this one is going to be a negative pi over 4, or I guess that's not the final answer. If you want to pull the negative out front, I like to do that. Therefore, this would be the final answer, negative pi over 4. Okay, so this lesson is titled Cross-Cancel Fractions, and it's pretty simple. If you have the same thing on the top as you do on the bottom, even if they're catty-corner to each other, as we like to say, you can go ahead and cancel them out. And if you cancel everything out, you're left with 1, not 0.